So in the previous video, we have completed up to methods of measurement of evapotranspiration. Okay. So we have written these three methods starting with the Lysimeter, Penmans equation and Blanik-Riddle's formula. Don't get confused with the Lysimeter and phytometer. So many times we get confused between these two. So phytometer, it is used to measure only transpiration. Okay, only transpiration is measured by using phytometer. But by using lysimeter, we are measuring both evaporation and transpiration. So this is the difference between phytometer and lysimeter. This phytometer we have discussed in the previous videos. Anyways, let's start with the first method, that is lysimeter. So give the heading lysimeter. So lysimeter is a tank which is filled. Lysimeter is a tank filled with soil and natural vegetation. Filled with soil and natural vegetation. Okay, so it is containing soil and certain crops, or we can say certain plants which are present. Now the sides of this lysimeter, the sides of this lysimeter sides of this lysimeter is impervious. And bottom is pervious. Okay, now so what we are doing is we are having a circular tank, or we can say a tank which is having some soil and individual crops. So we are taking the initial weight of the container which is having the soil and plant, and that initial weight of the container we will denote it with Wi. Okay, so it will contain the original weight or initial weight of lysimeter, or what we call it as tank or container. Okay, so it will be having container weight plus soil weight plus plant weight plus some moisture that is present. This is the initial weight. Now this lysimeter or this tank which is having soil and natural vegetations, this is, or we can say water is added to this lysimeter. So certain amount of water is added, so that we will denote it with water added, so Wa. Okay, so it is water added. Now what happens during evapotranspiration is that plant's root will take the water and it will use for its growth, and certain water will be lost for evaporation. Okay, so some of the water will get lost. So once the water which is added, out of this water certain amount of water will get lost and remaining water will come down and get collected at the bottom. How it can get collected at the bottom? Because the second point, you can see this sides of lysimeter is pervious whereas the bottom is pervious. That means the water cannot flow laterally, it can only flow downward, vertically downward. So we will get the water which is collected at the bottom, that we will name it as Wb, and it is water collected at bottom. So water collected at bottom. Now the last thing that is there, Wf, this will be the final weight of container content. Final weight of container with its content. That means this soil, plant and moisture. So once we do some mathematical calculations on this, we will get the amount of water which is lost, and that will be equal to evapotranspiration loss. So now this pay attention here. So actual evapotranspiration, AET. So this will be equal to original weight of container plus soil plus this. So it will be Wi. So original, what is the weight? Then some water is added. So we'll add that water. So Wa. Now certain water is collected at the bottom. So we will subtract this minus Wb. And also we will subtract the weight of container with its content. That is the final weight. If you do this calculation, then you will get the water which is lost during evaporation and transpiration combinedly, and that loss we will be calling it as actual evapotranspiration. So this is the use of lysimeter. Okay, it is very easy, not much questions are asked on this, only the term is important, lysimeter. For what it is used? It is used for evapotranspiration calculation. Now for the other exams like ESE, you can also go in deep up to this calculation of AET. So this much points are important from the lysimeter. Okay, so let's go with the next method now. So this is the empirical method. So we just have to learn the formula here and the units of it. So the remaining two methods I am writing here directly. So the second one is called as Penmans equation. Penmans equation. Is it an empirical formula or analytical formula? It is an empirical formula. Whenever you learn empirical formulas, learn it along with the units, because the units are important and it is generally asked in the exam. So potential evapotranspiration, PET, it is equal to A into Hn plus E into Y for gamma divided by A plus gamma. So this is the formula. Now here the units are important of each and every term. So potential evapotranspiration, PET, it is measured in mm per day. Mm per day. Then what is A here? So the A is slope of PS versus temperature graph. So PS versus temperature graph, slope is A. Then Hn is net radiation. Net radiation. Then next is E. So E is constant for wind velocity and saturation deficit. So it is a constant value. Then last is gamma. So this is asked in the exam many times. So write it properly. Gamma is called as psychrometric constant. Psychrometric constant. Very important. I'm giving here star mark also. And the value of this psychrometric constant is 0.49 mm of mercury per degree Celsius. Okay, so this is the Penmans equation. It is used to find out the PET, and these are the values. Now coming to the next one, that is Blanik-Riddle's formula. So here, as the temperature is given, so I am just giving here one note, that is conversion of degrees to Fahrenheit. So 1 Fahrenheit, or the Fahrenheit, it is equal to 1.8 degrees, that is 1.8 into degree Celsius plus 32, where F is in Fahrenheit and C is degree Celsius. Okay, so this was the Penmans equation. Now coming to the last one, that is Blanik-Riddle formula. See, in the exams, this name of formula is asked. Okay, only up to that point it is asked, but still we are going to the formulas also and the units in formula, just in case if they ask in the examinations, that is the central level examination, this can be asked, that is whether it is a empirical formula or a analytical formula, and sometimes maybe they will give a small problem also, so we have to be ready for that. So in this case the PET, potential evapotranspiration, it is equal to KTPM divided by 100, KTPM divided by 100, where important now, PET is potential evapotranspiration and it is measured in inch per month, inch per month. That means if we substitute these values here, we will get the potential evapotranspiration in inch per month. If you just go back to the formula which is given by Penmans equation, what was the unit of potential evapotranspiration in this formula? Mm per day. In this case, inch per month. So this is how there is a difference here. Then here the K is given. The K is called as crop factor. Crop factor. Sometimes it is also called as consumptive use factor. Consumptive use factor. It is equal to consumptive use divided by pan evaporation. So just write down this formula here. K, it is equal to consumptive use divided by pan evaporation. Okay, then next is, after K, next is T. So what is T here? T is temperature in Fahrenheit. Temperature in Fahrenheit. And how to convert degrees into Fahrenheit? So Fahrenheit is equal to 1.8 Celsius plus 32. Then the last one is PM. So PM, it stands for percentage daylight hours in month. Percentage daylight hours in months. So it is in months. Okay. So that's it with these formulas here. Now we have discussed all the three formulas for calculation of evapotranspiration. The first one is a method, that is lysimeter. Then the remaining two, Penmans equation and Blanik-Riddles, these both are the empirical formulas. It is necessary at the basic level to understand or to remember the name of the formulas initially. That is, if they are asking for what purpose lysimeter is used, then you should be able to answer that it is used to measure transpiration, or it is used to measure the evapotranspiration. If in question phytometer is given, that means it is used for transpiration. Then this Penmans equation and Blanik-Riddle's formula, this is used for what? This is used for the measurement of evapotranspiration. So these are the initial concepts that you should first learn. Once you are familiar with the name of the formulas and each of these methods, then you should go in depth about each of the method. Like Penmans equation, what is the formula, then what is the unit. Up to now I have not seen much questions which are asked calculation point of view from this topic. Most of the questions are direct questions. However, if the question is given for calculation, then we should be in a position to calculate it. Okay. Okay, so that's it with this evapotranspiration. Now from the next video we'll start with the interception and then infiltration.